Let's go and take a look at problem number 1. Here we're looking to find the limits numerically. So this is where you're going to plug in values, right, close to where we're trying to evaluate the limit. So in the first one, you have a function. Again, these are always in calculus kind of crazy looking functions because it helps us analyze behaviors of all functions at some point. And so you have this function here. What is its value? You can see that the values I'm approaching 0, I'm going to plug in numbers from the left and right side. And that's the key. Remember, when we're going to evaluate a limit, we want to make sure when it's evaluating at a point, right, we want to evaluate the left and right side. And so when we do that, I take a look and I see as it approaches 0, I plug in values as I get closer and closer to 0 from the left and right. And again, this is still just an approximation, an estimation. And so you can see it looks like I'm getting closer to, as we get there, 1.608, 1.6 or 10, right? You can then come to some number. It depends on the values you're plugging in, but it's the process of plugging in values close to it. To what it's approaching. This one's also going to 0, and you can see it looks like this approaches 0 also as I plug in values closer and closer to 0. And again, what's kind of crazy is if you plug in 0, you get an undefined, undetermined value, and that's what's kind of interesting is that there's still values as you approach, right, the limit as you get closer to 0. There are existing values, just that at 0, right, the function doesn't exist. And the other ones here are going to positive infinity. I think both of them are. I can see that, right? As you get bigger and bigger and bigger, for this one here, it goes to positive infinity, and you can see it looks like I'm getting closer and closer to 0.000 here. It looks like you're going to get closer and closer to 0 as we do that. These values are getting smaller and smaller. You can plug in bigger numbers than 500. The last one's interesting because this is the one that has oscillation that goes up and down, and that's because of the behavior of the trigonometric functions. Trigonometric functions are periodic. They oscillate. They go up and down. They up and down. There's many things in our world that behave with this periodic nature, and so you're going to get graphs like that. And so the limit goes back and forth as you approach infinity, goes up and down. And that's again because the sine function is positive or negative, right? It stays within positive or negative 1. And so this x acts like an amplifier. And that's why this one is indeterminate too, because it just goes up and down, and back to positive and negative infinity in different values. So that's the process of evaluating limits numerically.